So today we're covering lessons 2.7 and 2.8 in the Algebra 1 book. We're going to be looking at addition and subtraction facts, and we're also going to be looking at multiplication and division facts, specifically related to equations. So basically, we're going to talk about solving one-step equations, which goes all the way back to almost 6th grade level work, but obviously we're taking things to the next level. And we're going to be working towards solving equations. And again, that's all somewhat review, but we were prepping you for what's going to come in algebra. So while some of it feels like you've done it before, we're obviously going to be taking things to a higher level than we did in middle school. So starting with 2.7, we're going to be looking at the addition property, and we're going to be looking at the subtraction property of equality. So that's our big idea. The addition property of equality explains how addition and subtraction facts are related, and it helps us solve equations in the form a plus x equals b, which is a one-step equation. Okay, so we know how to solve these already. We're going to kind of just work through it. So you should already have these copied down, but let's talk through them. The addition property of equality says if a equals b, so you have two things that are equal to each other, then a plus c equals b plus c. So what does that mean? Because when you look at this, this just looks like a bunch of kind of math stuff. So let's break it down. So you have two things equal to each other, and then it says, well, I added c to a and I added c to b. So I added the same thing to both sides, and now it's equal. Why does that make sense? Well, if you have something that's really obvious, like 10 equals 10, and now you're going to add the same thing to both sides. 10 plus 2 equals 10 plus 2, right? So 12. So if you have an equation where both sides are equal, you can add to both sides, and they're still equal. Okay, that's a property of an equation. So subtraction is very similar. If a equals b, then a minus c equals b minus c. So again, if I have two things that are equal to each other and I subtract the same number from both sides, I would still have an equal equation. So if I had 10 on both sides and I subtracted 2 from both sides, it's going to say 8 equals 8. So both sides are still equal. Now the additive inverse property basically says that if I have some number and I add the opposite of it, the result is always 0. So whatever the number this is, 8 plus negative 8 is 0. And even if I don't know what the number is, if it's a plus negative a, it's going to be 0. Any number plus its opposite gives you 0. And the additive identity property basically says if you have any number, so we're just going to use a, and you add 0 to it, you still have that same number. Something we know to be true, you add 0 to anything, 7 plus 0, you still have that number. Even if it's a negative number, if you add 0, you still have that number. So that's called the additive identity property. So we're going to look at these fact triangles, something you probably haven't necessarily seen before. And this is going to kind of help us work through solving some equations and maybe just look at them a little different than we're used to. So how you read these is you either go straight across and then up, or you can go this direction and up. Or if you're going down, you're going to pass the subtraction. So what do I mean by that? So if you want to start here, you can write this as negative 12. If you're going across here, you're going to use the plus sign. 7 equals the top number, negative 5. So if you're moving across the bottom, you're grabbing the plus sign. Negative 12 plus 7 equals negative 5. We know that to be true. You can go the other direction. You can say 7 plus negative 12 equals negative 5. But I think the more important direction is going down. So when you're going from the top number, so if you're starting with negative 5 and you're going either to the 7 or the negative 12, you're grabbing the subtraction sign along the way. So negative 5 minus 7, what does that equal? Negative 12. What if I go this way? Negative 5 minus negative 12. Well, this goes plus plus, and it's negative 5 plus 12, and that is 7. So for every one of these fact triangles, what's created are 4 equations that are true. So if two numbers being added together equals this top one, I can subtract either direction and still end up with the third number. So let's try building one with fractions. If I add the bottom two, so 1/2 plus 1/4, I should get 3/4. And I do, because if I change this to fourths, 1/2 is like 2/4, and 2/4 plus 1/4 is 3/4. I can go the other direction. So 1/4 plus 1/2. Commutative property says I can switch the order and I still get the same answer. But more importantly now, if I take 3/4 and I subtract 1/4, I should get 1/2. Now I get 2/4, which is equal to 1/2. So yes, it works. And what if I go the other direction? So I have 3/4, and I'm going to subtract, go this way, 1/2. So that equals 1/4. Because again, this would be 2/4, and 3/4 minus 2/4 is 1/4. All right, so let's now take these fact triangles and let them help us solve equations. If we go to the next page, we're going to build our own fact triangle to help us solve these equations. Now, I know that you already know how to solve these equations, but bear with me. We're going to use the fact triangle so you can kind of see how this works. So we're just going to draw a triangle. Now, these are the two values that are being added. So those are the two that need to go on the bottom. So the y plus the -6. It's going to equal 14, and you can put the minus here. Let's go ahead and build this one while we're doing that. I'm going to give you a second, see if you can build it yourself. So the two numbers being added are 13 and the number that A represents. So they're going to go down here. Those are the ones I'm adding together, and they're going to equal 3. So according to these fact triangles, the addition part is pretty obvious, but I can use this to solve for y. So if I want to know what y equals, 14 minus -6 equals this number every single time. So 14 minus -6 equals y. And you could put the equals y on either side. It doesn't matter. So what's 14 minus -6? You go plus plus, and that's 20. So y equals 20. So in this equation that we started with, something plus -6 equals 14. It's 20. So if we're going to use this one, all right, 13 plus a equals 13. Equals 3. And so if I'm going to move this direction, 3 minus 13, coming down the fact triangle, that equals a. Well, what's 3 minus 13? That's -10. So if I go back to my equation, 13 plus something is 3. 13 plus -10 is 3. A is -10. All right, so now let's use the addition property, because we don't need to draw these triangles every time, but they are kind of helpful and get your mind to kind of think a little differently about how this works. So now this is going to look more like what we did in 6th and 7th grade, and then obviously in 8th grade when we took things to a higher level, solving these equations. The addition property says I have two things that are equal, so this side equals this side. I can either add the same number to both sides or subtract the number on both sides, and they're going to stay equal, which means I'm allowed to do it. So my end goal here is to get x completely by itself, which means I kind of want this 10 to disappear. I want to take 10 away from this side. Well, I'm allowed to take 10 away from this side and have this stay a true equation as long as I take 10 on this side. Because if these two sides are equal and I take 10 away from both of them, they're still going to be equal. So what that's going to do is 10 minus 10 gives me 0. So they basically go away, leaving me just x. And now all I have is -19 minus 10, which is -29. And I have solved my equation. X plus 10, some number plus 10 equals -20, equals -19. It's -29. Let's do a check real quick. Nobody likes checks, but let's do it. X plus 10 equals -19. Plug in our answer. So change x to -29. And if a check works, both sides come out equal. Well, what's -29 plus 10? You should always double check it in your calculator. It's -19 equals -19. We're good. Okay, so similar over here, but again, we want to get this to 0. So I can subtract from both sides or I can add to both sides. What I want to do is end up with r by itself. So this value over here needs to end up at 0. So how do I get a negative 10 to 0? Well, what's the additive inverse? If I add another negative 10 to negative 10, I don't get 0. I get negative 20. So I don't want to add another negative 10. I want to go from negative 10. I want to just add 10. If I add opposites, I get 0. So if I have negative 10 over here, I want to add positive 10 to get to 0. So I need to add positive 10 on this side so that my equation stays true. As long as I add the same number to both sides, I'm good. So R equals 35. And if I come over to the third equation over here, I want to get B by itself. So I want to get this 9 to a 0 so it disappears. So I can either add negative 9, you can always add the opposite and get it to 0, but adding negative 9, we've talked about, is the same as just minusing 9. So whichever way your brain works, we just got to get this to 0. So 9 minus 9 is 0, leaving me just B. 12 minus 9 is 3. And I've got my answer. And we could run checks here, but this is basic enough. We're just going to leave it like this for now. All right, so that's adding and subtracting, and that's 2-7. All right, and I think based on what I know about how much you learned in middle school, I think we can do more than just this today because this is pretty basic stuff. All right, so let's look at multiplication and division and get all of this wrapped up in one shot. So if you go to the next page, we're looking at now 2-8. All right, and we're going to basically do the same thing, but with multiplication and division. So your multiplication property says if A equals B, then you can multiply both sides by the same number, and it's still equal. So we've got equal numbers here, and I'm allowed to multiply both of them by the same number, and I still have an equation. So let's go back to easy numbers. If 10 equals 10, then that means 10 times 2 equals 10 times 2, and it does. Okay, that's why this works. So if I have two numbers that are equal, and again, this could be represented by something other than 10 in terms of like a variable. So like A times B equals 10. And if I multiply this side by 2 and this side by 2, they're still equal. As long as they started off equal, I can multiply both sides by the same number and they're still equal. And division says the same thing. So if A equals B, then I can divide both sides by the same number. So A divided by C equals B divided by C. All right, so that's basically what allows us to solve these equations. Now, we want to talk about the multiplication property of 0. Pretty straightforward. Any number multiplied by 0 gives me 0. So what's the difference between that and the 0 product? The 0 product property basically says, and this isn't from the textbook, this is kind of my own words here. If the product of two numbers is 0, then what do you know? If you have two numbers and they're being multiplied and the answer is 0, we know that one of them is 0, or both of them could be. But at least one of them is 0. If you multiply two numbers and you get the answer of 0, at least one of the two is 0, maybe even both of them. Now, these are going to be really important. The multiplicative identity property. That just means anything times itself. Anything times 1 is itself. So it doesn't matter what the number is. If you multiply it times 1, you get itself. And then this is the one that's super important. It comes from this property. So A times 1 over A equals 1. So if you multiply anything times its inverse, you're going to get 1, and that's very important. So inverse is kind of like flipping the fraction. So if we have this number, A, well, A is anything like over 1. And so if I flip it, it becomes 1 over A. You multiply straight across, you get A over A, which equals 1. Sometimes it's easier if you have the actual numbers. So if I have 5 and I multiply it by 1/5, I should get 1. Why does it work? Because 5 is really 5 over 1. And so if I multiply it times 1/5, I get 5 over 5, which equals 1. All right, so let's jump to the fact triangles. So they work exactly the same. I can write 4 different equations here, so you can kind of get ahead of me here. Just write the 4 equations. I would start with the easy one straight across. 5 times 6 equals 30. You can go the other direction. 6 times 5 equals 30. They're commutative. But now going down, 30 divided by 6 equals 5. And then 30 divided by 5 equals 6. So those are all the facts that I can pull out of this, kind of just putting things in different orders. But let's look over here now. This is interesting. So 1/2 times 18 equals 9. It's really important that we start to see that. When you multiply by a half, you get half of the number. Going the other direction would be true. 18 times 1/2 equals 9. But let's go the other direction. 9 divided by 18 equals, and at first you might say 2. Well, that's 18 divided by 9. We're doing 9 divided by 18. Small number divided by a big number gets you a fraction. It's 1/2. And then 9 divided by 1/2 equals 18. And that's the one that blows everybody's mind at first until they think about it. Because they say, I divided, how is the number getting bigger? Right? When I divide, things get smaller. Well, that's not always actually true. 9 divided by 1/2, or any number less than 1, will give you a larger number. So just to prove it, we know that to divide, we KFC, we flip. So this is really 9 over 1, and I can change division to multiplication as long as I flip and take the inverse on this side. And then what do I get? I get 18 over 1, which is 18. So 19 divided by a half is 18. Okay, so dividing by a half is the same as multiplying by 2. Let's jump to the last page. So we want to solve this using a fact triangle. So let's draw the triangle. The 2 values that are being multiplied go on the bottom. So that'd be 16 and our unknown number, so x. Those are the numbers being multiplied. And 192 is going to go up here. So if 16 times x equals 192, what do I know? Well, I know 192 divided by 16 equals x. So I can just run that in my calculator. 192 divided by 16 is 12. Now, what if I wanted to use the division property, which is what we're used to, which is what all of you are probably going to automatically go to. You have 16x equals 192. I have an equation. That means both sides are equal. If I divide them both by the same number, they're still equal. So what I want to do is I want to divide both sides by 16. And again, this is probably automatic for you guys at this point. Why do I do that? 16 divided by 16 is 1. So I end up with a 1x, or just x. And then over here, when I divide, I get 12. So since I divided both sides by the same number, both sides are still equal. But now I have x by itself, so I know its value of 12. Now, how could I do this with the multiplication property? How do I solve this with multiplication? So I have 16x equals 192. How do I get rid of a 16 by multiplying? I can divide by 16 and get 1. How do I multiply and get 1? So it's going to come back to, if you flip to the front, comes back to the multiplication or multiplicative inverse property. If you multiply any number by the inverse, so the flipped version of it, you're going to get 1. So I'm trying to get 1. I just want a 1x. So what do I multiply 16 by? The inverse. This is really 16 over 1. So if I flip it, it's 1 over 16. If I multiply 1 over 16 times 16, I get 1. So I'm going to multiply this side by 1 over 16. Think about why this works, because really 192, you're going to put it over 1. When you multiply straight across, you're going to get 192 over 16, the same as we ended up with over here. So this is kind of the same math, and it's 12. So 3 different ways to go about this. Obviously, this is the most concise, so this is where we always start. But it's important to understand that these say the same thing. So multiplying by 1/16 is the same as dividing by 16. Okay, so now we're going to talk about kind of some sets of numbers. We want to solve this. 0 times some number equals 0. If you told me that x was equal to 1, that's true, but is that the only answer? Is 1 the only answer I can plug in? No, 0 times something to get 0, it could be 2, it could be 3.5, it could be 8, it could be -10. All of these numbers can be plugged in for x, and this is still true. So I have to represent all of these numbers as my answer. I can't just pick any one. If I just pick one, I say that's the only answer. And all of these are answers, and there's an infinite number of these. So you could say all integers, but that would only be talking about whole numbers. And so what set represents fractions, decimals, and negatives? That's all real numbers. And there's a nice little way to represent that. The symbol for it is a double R like this. So you're going to kind of draw an R, and you're going to put an extra little bar or stem there. And that represents all real numbers. These mean the same thing, all real numbers. Now, what about this one? 0 times something equals 4. Can 0 times anything ever equal 4? And the answer is no. So this is represented by a 0 with a slash through it, sometimes called the null set. That's what this symbol actually represents. Basically, there's no answer. You must put the slash, because if you put 0, 0 times 0 is not 4. So the 0 through the slash basically means that there is no answer. It's the null set. And another way to answer it, a different way, is to put a set of parentheses. Now, these are kind of fancy parentheses that they use for sets, but with nothing inside of it. And this is called the empty set, because there's nothing inside. There is no answer. There's no answer that we can put in. 0 times anything is going to be 0. It's never going to equal 4. Now, what about this one? 13 times something equals 0. Well, when two numbers are being multiplied and the answer is 0, I know one of them or both of them is 0. So if this one's 13, I know that x equals 0. And I can prove it by dividing both sides. This was multiplication, so if I divide it on both sides, I still have an equal equation. 13 divided by 13 is 1x, and 0 divided by 13 is 0. So take a look at these 3 questions. I have 3 totally different answers. This basically is any number in the world I can plug in, and it works. So there's a big set of numbers that represents x. It's all the real numbers that exist, which is an infinite number. This exact opposite is the null set. There is no answer. It's basically impossible. 0 times something cannot equal 4. So this is all real numbers. This is no numbers, and this is 0, and 0 is a number. Okay, so this has an infinite number of answers. This has one answer, and this has no answers. It's impossible. I mean, it's very important to see the difference. All right, last one. Example 4, and I know this has been long. Thank you for bearing with me. We're going to find the reciprocal of each number. Reciprocal, kind of like the inverse. You're flipping it. You're pretending it's a fraction, or not pretending. You're turning it into a fraction and flipping it. If it's already a fraction, you're flipping it, and we'll talk about how do we handle the decimal. So what is the reciprocal, or kind of the inverse of -34? Well, it doesn't change signs, so it's still negative. Pretend 34 is over 1. And again, don't pretend, it actually is over 1. And you flip it, and so it's 1 over 34. So that's the reciprocal. Now, how do you prove it? We'll do a quick little proof. The proof is, if you multiply the two together, you should get 1. Okay, that goes back to our multiplicative inverse property. Okay, you multiply the number times the inverse, or the reciprocal, and you're going to get 1. So -34 times -1 over 34 has to equal 1. Well, this is really over 1. Any whole number is over 1. All right, and when you multiply across here, a negative times a negative is a positive, 34, and I get 34 on the bottom, and that equals 1. Okay, so this works. So I know that it's the reciprocal if I multiply the 2 and I get the number 1. So 4/15 is already a fraction. So the reciprocal is 15 over 4. You just flip it. What's the proof? 4 over 15 times 15 over 4 has to equal 1. So if I multiply straight across, I'm going to get 60 on the top, 60 on the bottom. Therefore, the answer is 1. And it's good. So 15 over 4 is the reciprocal. So the reciprocal is basically the flipped version of the fraction. So what about this one? It's not a fraction. It's a decimal. It's not a whole number. But that doesn't mean I can't just put it over 1. I can. This is really over 1, even though it's a decimal. It's still over 1. So the reciprocal is just flipped. So it's 1 over 1.5625. Now, you're probably not very much used to seeing a decimal inside a fraction because we really don't work with that much at the younger grades. But again, this is really division too. So can you divide 1 by a decimal? Sure. So you can write it as a fraction. Perfectly fine. Now, what if I want to test this out for my proof? Of course, you're going to use a calculator. But how do I plug this into my calculator? Well, let's turn this into its own little decimal. Okay, so 1 divided by 1.5625. If you plug that in your calculator, one divided by 1.5625, you get 0.64 or 0.64. So the reciprocal of 1.5625 can be represented by this fraction, but that's equal to 0.64. So these two numbers should be reciprocals. So let's prove it. Let's multiply the two numbers. So 1.5625 times 0.64. What's your prediction? It should be 1. If these are truly reciprocals, the answer should be 1. So 1.5625 times 0.64 is 1. So now I know that 0.64 is the reciprocal because 1 divided by 1.5625 equals 0.64.